Hello Lockerbie, and today we are going to get on with a difficult problem that most people have, and that's the difference between mass and weight. And if we can explain that to you, we've had a really good lesson.
What is the difference between mass and weight? I think it's something that a lot of people are confused about. They just think that anything that's big, like this car, has a lot of weight. It's very heavy, it's got a lot of mass. And people just basically think of these ideas as all the same. But there's an important distinction between the terms mass and weight. Mass refers to the amount of matter in an object, whereas weight is a force. It's the gravitational attraction that the object feels towards, in this case, the Earth's center. So I've got a little experiment today where I brought my car out here. I'm going to ask some people, why is it difficult to push my car? And my bet is their answer will be because the car is heavy.
Mass. Anything that takes up space is matter. The amount of matter in an object stays the same, whether the object is on the Earth, floating in space, or on the moon. It's the same object, its mass remains the same. Mass is a measure of the amount of matter in an object. Mass is caused by the number of particles in the object. Particles are too small to be seen, so we deal with larger bundles called kilograms. If you have more particles in your body, you will have a greater mass. We use the unit kilogram to measure mass. So the kilogram is the unit of mass. So let me explain. Here we've got a box of Rose's chocolates. If I took those home with me and opened them up, there would be the same number of chocolates wherever I took them. So you can have so many dairy milks, so many of those nice purple ones that are my favourite. Now, if I put them back in the box, closed the box and took those to my friend, and then we opened them together, they would still have the same number of chocolates. Providing I didn't eat them, the mass of those chocolates, wherever I took them, would be 400 grams. I could even take them into space, open them up on the International Space Station, and it would still have the same number of dairy milk chocolates. So the mass, the number of particles, that stays the same. Likewise, if you have a mass of 50 kilograms, which is about 8 stone on the Earth, doesn't matter where we put you, your mass will stay the same. If you go to the moon, around the middle of the space, or anywhere in the universe, you will have a mass of 50 kilograms because that is a measure of the number of particles, the amount of atoms in your body. That is, of course, assuming you don't go on a diet or you don't do a massive number 2. Mass is really about inertia, and inertia is the tendency of an object to stay where it is. So solids prefer to stay where they are. They don't move unless we apply a force. The bigger the mass, the harder it is to move. So inertia is a tendency of an object to remain at rest or carry on moving unless you apply a force. That's it. It's the resistance of an object to motion. So for example, if you jumped out in front of a child on a little tricycle, you probably would feel that you'd be able to stop that little kid from cycling out into the middle of the road. But you probably wouldn't step out in front of a bus and try and stop it moving. Why? Because the bus has a greater inertia, a greater tendency to carry on moving, and the little kid on the tricycle has a smaller inertia or a smaller mass. So mass doesn't move unless it's forced to. So if something has a big mass, it's hard to get going and it's hard to stop. And I want you to have a go at looking at the videos on this and then see if you can try this at home. So what is this thing called weight? Well, weight is the pull of gravity on an object. The Earth has a mass, and the mass of the Earth pulls things towards it. And the pull of the Earth on other objects gives them weight. Now, the mass of Jupiter is much greater. So the pull from Jupiter, the planet, will pull objects with a greater force. So objects on Jupiter will have a greater weight for the same mass. Likewise, the Sun has an even greater mass. So it's got a greater gravitational pull. So it will pull objects towards them with a greater force. So if you went towards the Sun, apart from the fact you'd burn up, you'd have a greater weight. So our weightlifter in the picture here is having to pull up or lift against the force of gravity. And you could do the same thing on Jupiter, you would find it much more difficult to lift those dumbbells because of the pull of gravity on Jupiter is much bigger than the pull of gravity from the Earth. If you could do exactly the same experiment on the Moon, you would find that lifting those would be much easier because the pull from the Moon is much less than the pull from the Earth.
This has been a good event for Kevin. The key for him and everybody else is to get the balance right once he takes the weight on his shoulders.
5 years ago, when we first met Kevin, he was a full-time student at Arizona State University, originally from the Boston area, now making his home in Arizona, and he's got this thing moving.
So is there a link between the mass of an object and its weight? Yes, there is. We know that mass is the amount of matter in an object, which is measured in kilograms, and weight is the force of gravity on an object. So weight is measured in newtons. On Earth, the pull on a 1 kilogram mass is 10 newtons, and that's what you did when you did the Hooke's law experiment. If we're in school, we would get a 1 kilogram mass and put it on a spring balance, and we'd find that it had a force of 10 newtons. So for every kilogram of your mass, you're being pulled down to the Earth with a force of 10 newtons. This force for every kilogram of mass is called your gravitational field strength and is given the symbol G. So it's like the strength of gravity. And gravitational field strength on the Earth is about 10 newtons for every kilogram, or 10 newtons per kilogram. So if we want to find the relationship between mass and weight, then we take the mass in kilograms and we multiply that by the value of the strength of gravity. And in this case, it's 10. So if we take our mass in kilograms, times it by 10, we will find the weight of any object on the Earth. So here is an example. We know that a mass of 1 kilogram will have a weight of 10 because W, weight, is equal to mass times our gravitational field strength. So 1 times 10, which gives us 10 newtons. If we've got a mass of 6 kilograms, that's 6 times by our strength of gravity, which is 10. 6 times 10, 60 newtons. An average apple has a mass of about 100 grams. So that's 0.1 kilogram. So 0.1 kilogram times by my strength of gravity, 10 newtons. The weight of my apple is 1 newton. Have you got the idea? We can represent this as a triangle and you can cover up what you want to know. So if you want to know the weight, cover up the weight, and that tells its mass times the strength of gravity. If we want to find the mass, we take our weight and we divide it by our gravitational field strength, or strength of gravity. If we want to find the gravitational field strength, we take our weight and we divide it by our mass. So there's some calculations for you to have a go at, and we'll give you the answers later. So see your teacher if you've got any problems with that. Thank you.
Mass and weight. Mass refers to the amount of matter in an object, whereas weight is a force. It's the gravitational attraction that the object feels towards, in this case, the Earth's center. So I've got a little experiment today where I brought my car out here. I'm going to ask some people, why is it difficult to push my car? And my bet is their answer will be because the car is heavy.
Because it's heavy.
Too
heavy.
It depends if it's uphill or downhill, but the car's heavy.
Big rock you would think would be heavy. Anything that's big you would think would be heavy. It's too heavy. It's heavy. Oh, it's a bit lighter than I thought.
It's got its weight.
Weight is responsible.
What is weight?
Weight is mass in a gravity.
What is this gravity thing?
Gravity is
Gravity's
what
like
keeps
the pull of the core of the Earth.
Your car is pulled towards the center of the Earth.
Yes.
But now when you push it, let's say you're pushing your car, you're not pushing it up, you know what I mean? But it's still hard to push.
Yeah.
So do you think weight's responsible for making it hard to push?
Well, it is weight. I mean, like, the lighter the car, the easier to push. So, yeah.
Like weight only
Because
exists
weight and
because of
gravitation.
gravity on the map.
But I'm not trying to lift the car, right? I'm just trying to push it.
It's really
You have
good
like a
question.
huge, like a big rock you would think would be heavy. Anything that's big you would think would be heavy. So a car, but I'm not lifting it, I'm pushing it. So
Well,
it's the gravity of it, I suppose.
But this is my question,
Yeah,
right?
yeah.
But I'm not trying to lift it,
No, that's true.
but
Pushing
it's still hard to push. So why is that? Because like if I lift it, I understand you
it
saying
would
it's
be
heavy,
Yeah,
and then it would be really hard. But we're pushing it and we're actually getting it to go.
true.
So how does that work? The answer is Because the car has inertia. Inertia means that objects with mass have a tendency to resist changes in their motion. And I thought she had a great answer when I started, which was inertia. Can you tell us about that? What's inertia all
Just
about?
like once something's stopped, it doesn't really want to go, and once something's going, it doesn't really want to stop.
Yeah, well, the idea that I'm trying to get at is there's actually two different things, right? One thing is that there's a force pulling the stand into the earth, and that's what we call weight, and that makes it impossible to lift. But there's something else which is called inertia, and that means something is difficult to change its motion. The car's got a lot of inertia, and that's why it's difficult to push, which is different than why it's difficult to lift, which is the weight force pulling it down towards the earth.
Fair enough, but it's actually not as difficult to push as
It's not that hard.
Yeah,
Yeah.
actually.
I know, it doesn't even prove my point, because you can push it with one hand, can't you?
Absolutely.